Good morning, friends. Today we are going to discuss about another important domain of casting, that is design of core. This core is very much important. The reason is that it is responsible for creating some hollow structures in the casting. Why it is done? The reason is that otherwise one has to machine that hollow surface, and that will be a time consuming and costly affair. So it is always better to create all those hollow structures through the casting at the time of casting, so that the energy and cost is saved. But the criticality is that how to design the core and how to place the core in the casting, because the core will remain inside the casting even after pouring of the molten metal, and their position is important, and many a time their alignment is strictly important. Otherwise, what will happen that there will be defective casting if the alignment other things are not properly done. So one has to be very alert in order to appropriate placement of the core. So set of cores are also sometimes used for casting sand cores to make shapes and spaces inside a mold that the original pattern cannot create. Original pattern cannot create because pattern will be removed, and if it is removed, then the solid casting will be there. No question of the hollowness. So these things has to be there at the time of pouring of the molten metal. Then and then only, truly speaking, the hollow section will be produced. So the definition of the core comes is, it is a device used in casting and molding process to produce internal cavities. Internal cavities are always critical and difficult to produce. To produce internal cavities and reentrant angles, an interior angle that is greater than 180 degree. So those kind of challenging angles will be produced by those core. So core is a sand or a metal insert. It has to be inserted, used to shape any part of a casting that cannot be shaped by the main removal pattern. What pattern cannot do, core will do that, and it will remain in the mold at the time of molten metal pouring activity is there, and that is important. So what will be the features? They have some features of those core. This core is normally a disposable item, expendable item, sacrificial item for each of the casting process has to be done, and that is destroyed to get it out from the piece. So it has to be collapsed. The sand of the core has to be collapsed and taken out of it to make the appropriate hollow sections in the casting. It is destroyed. And one model of, say, some engine, GM, some variety, GM V8 engine requires 5 dry sand cores for every casting. Why dry sand? Because it should not have a lot of moistures. Because if the moistures are there, then a lot of steam formation, and steam will have the escape route, and that will jeopardize the surface of those things. So dry sand cores are required, and maybe a 5 set of dry sand cores are required for every model of engine to be cast. What is the application? When pattern is pressed into the sand and then extracted, the impression it leaves must be concave, because concave sections or other things are provided, not convex, so that easy withdrawal of the pattern. The main challenge of the pattern is that appropriate withdrawal, where the pattern is reusable, it is not sacrificial. In case of investment casting, there is no question of withdrawal of the pattern because the pattern is melted away. But other than that, where the patterns has to be used over and over again, so withdrawal strategy of those pattern is complex, and that has to be created very specific shape that is concave, and cores allow more complexity in the design. Cores enable a casting person to go for very intricate type of design, and in one go those complicated shapes will be there where less amount of machining has to be done. So wherever there are complexities and hollow sections, core has a role to play. And with well constructed core, judiciously selected core, the foundry can create holes or chambers in the casting very easily, but their placement is very critical. So automobile engine molds, because these automobile engine have to be created in large quantities. A country is known by the capability of automotive engine manufacturing capacity. Even in today, in the age of electric vehicles, still lot of automotive engine, IC based engine has to be manufactured, and their creation of all those hollow structures in those things, and the core has its significance. So engine molds might have 5 cores in them to create the chambers which are necessary for the working of a combustion engine. Because we know that in combustion engine the pistons has to reciprocate within the cylinders, and in order to create those engine blocks we have to create some hollow sections and core. If it is the engine body is a cast product, then definitely we can use the core in order to generate those critical hollow structures in that. And these cores can also help create angles that would be impossible with a pattern, where those kind of complexities pattern cannot handle. Core have to handle those things, and that is why it is a very good ancillary or a supporting device for the pattern which cannot be done by pattern. Core will do it. So any overhang above an empty space, that is again a very crucial part. Overhang above an empty space would make it impossible to withdraw. If it is overhang, you cannot withdraw. The pattern cannot be withdrawn, and without breaking all those things. So what will be there? The core will be placed maybe with some pins and with some kind of a very specific device that is called chaplets in order to position those cores in these overhang positions. So core is indispensable in those kind of cases. So the castings using internal cores usually have some opening. Why opening? Because those core sand has to be collapsed after the casting and the outer shell of the molding to extract these sacrificial coal after the casting through this opening and be plugged by mechanically during the finishing. So some outlet has to be there where those collapsed core sand after the casting has to be taken out of it, and those plug holes may be plugged by those with some external additions and other things after the casting, and that is sometimes necessary in order to do that. Otherwise the core sand will remain there. So the hollow structures are not emptied, and we need to empty those hollow sections through extraction of the core sand from some outlet. These cores are definitely made of some sand, but some other features that made of some sand that are designed to break down. So collapsibility is a very important role to play in case of, for the molds also collapsibility is important, but the core, the collapsibility is more important because it has to be appropriately collapsed, because those outlet may not be that big as it is happened for the mold. So collapsibility has to be ensured so that it can be easily broken down after the casting, and internal cores are quite literally shaken out, because after the casting there is one process called shaking, and that is done by on a vibratory screen where it is shook violently so that any sand attached to that from the external part of it or also the internal part of it in the form of core comes out of those cast product shaken out of the casting at the end of the process, and with the shaking activity it is easy to take out, easy to collapse and get it out of those hollow sections. This shakeout opening is also helpful for the placement of the core, because in the shakeout openings all those things will be put together of the overhanging pins, maybe chaplets, another part to placement of the core before casting. So in the next slides we will see that how the cores and exactly the display of the cores. So any place the core touches the mold is a place where the molten metal cannot flow, because wherever the sand is there, there will not be flow of molten metal. So get a consistent thickness of a metal core must some bridges space to filled out without touching any sides. So some kind of gap has to be made, bridges has to be made in order to flow the appropriate places of those molten metal. And to achieve this, the core normally is longer than the casting, so that it makes these appropriate formation inside the cavity held into place by divots and in the sand outside the casting. And in order to accommodate that, there are some kind of special arrangement is done. And this is the typical placement of the core inside an engine block before casting. So inside one can easily see in the left part of it there are these cores are placed. As the cores are placed, molten metal cannot enter into that part, only the periphery there will be there. So there the hollow sections will be created, and after that with the outlet those core has to be collapsed in order to retrieve from those cavities, so that the appropriate hollow structures in the casting will be created without much difficulty. But the placement and the alignment and the concentricity of the placements are very crucial, because otherwise there will be an alignment and other kind of error, and if appropriate metals is not provided after machining, that will be a defective casting. So their concentric placement of those cores inside those hollow structures of the mold is a very critical one. Only expert hand can do that inappropriately, and after a lot of trial and error people will find it out that what is the best strategies in order to place this core associated with that, because engine block is such a crucial part of an engine that one cannot have the defects allowed to creep into that because of the non-appropriate placement of the cores. So only expert hand and a lot of experience, sharp with experienced skilled person can do those placement of the core appropriately, but still there are the possibilities of error. Even the best manufacturing workshops and other things are also landed up with defective casting. So one can see those products which are created by the placement of the core and the hollow sections, and good quality hollow sections are produced, and that way the products are coming out of those things. In the next slide we can see the typical engine block with some generation iron engine block with some their designations and parameters, and we can see there are all those hollow part which is predominantly produced by the placement of the core, and definitely after that it needs machining. It is not a near net shape manufacturing product, but whenever appropriate placement of the core, that will ensure that those good amount of machining does not have to carry. The machining part is very limited. The reason is that already those hollow sections are created by the core. So one can pretty well appreciate in the engine block how the cores have a very big role to play, so that little machining or less machining has to be carried out in order to go for the finishing activity. If the cores are not provided, huge amount of machining and huge amount of cost associated with those things. So core are a magical device in order to reduce the time associated with those machinings of those engine blocks. So core making methods. In order to make those cores, definitely some established standard methods are there in order to make appropriate core so that they will behave appropriately in the designed way, in a certainty in the casting while pouring all those things without having some misalignment, so that the defective casting possibility of producing defective casting will be minimum. So cores are made by many of the same methods employed for the sand molds, very similar, but little bit of difference is there, because addition core blowers and screw feed machines are used. Core blowers is to, to dry, we have to do some special fast arrangement so that it is appropriately dry, and some screw feeding machine to ensure that the appropriate compaction of the core will be there, because core has to sometimes float into those surrounded molten metal, and sometimes some turbulence in the molten metal will be there, and if that turbulence is of a certain threshold limit, it will just break those cores, and once it is broken, then the entire casting will be defective. So screw feed machines will ensure that the good compaction of the sand core in the sand in the core is happened, and that is absolutely essential in order to maintain the strength, hot strength of the core during the casting. Even if the flow of the molten metal is turbulent and disturbing, core will retain its shape even at elevated temperature. So core blowers force the sand into the core box by compressed air at about 100 pound per square inch. So that will ensure that the sand is appropriate compaction, machine compaction, not by hand ramming, so that it is uniform and less defect comes out of it. And these core blowers also used for making all types of small and medium sized cores. It is just like, say, food producing industry. If one visits in a casting shop, people are producing the different kind of produce, as if they are producing some kind of, say, samosa, some kind of, say, cakes, another part of it in some kind of dye. People will find it out what they are producing, just like the food processing unit. They are producing all those smalls and bigs and other kind of products, and appears to be just they are producing some kind of food before they're frying another part of it. Just look like that, but compaction has to be appropriate level, otherwise the strength of the core will be jeopardized with the turbulent flow of the molten metal at the time of casting. And the cores produced at very uniform and high production rates are achieved because of the small die and other things with those blowers and appropriate compaction, appropriate use of the core making sands. Sometimes those casting houses require huge amount of production of core, and many activities, many hands, skilled hands are required in order to produce all those cores in substantial number of cases where huge amount of quantities has to be produced. A lot of people has to be engaged if the entire process is manual one, and that way that will supply all those cores required for those casting house which are producing those castings and other things in a huge quantity. So what is screw feed? Screw feed machines are used to extrude the plain cores, usually cylindrical, in the cylindrical shape where the symmetries are there. The screw feeds with the screws, and all those core sands are forced together to produce those symmetrical cylindrical objects. And the core sand is pushed through a die into a core plate with some die, and die will give the appropriate shape and dimensions of those things. And the use of these screw feeders is limited to the production of stock cores, the long extruded cylinder, where the symmetrical shapes are there and by the machine, and then it is baked and cut into the desired length. Sometimes the very long products are there and they are dried up, they are baked with some hot air or other kind of devices in order to remove the moistures, and then they will be cut across. So that will be the productivity, because extrusion is not dependent on the length. Long length material also can be produced by extruders. So once in one go, people will produce that, they will bake and they will cut across according to the dimensions. So the multiple cores will be produced from one extrusion, batch extrusion results. And the core dryers, they are also absolutely necessary in order to remove those moistures, and they are like cake pans in that you support the shape of the core while it is in the core oven baking. In some oven will ensure this removal of all those moisture contents present in those core sands, and these are all core dryers. Or cone oven, it is just like baking of a cake, and these are usually light skeleton iron or aluminum boxes where internal shape of which conforms closely to the core portion of the core, and that kind of shapes are also imparted, and cores that would crumble or have parts break off when they place on a flat plate go through the oven in a core dryer. So those kind of strategies has to be adopted and in order to ensure the appropriate quality of the casting. And what are the features of the standard core? As usual, the features of the moulding sand. The first one is permeability. The escape route for those entrapped gases has to be provided. Otherwise, they will be remain there and will be the cause of concern of defective casting. So permeability is a very important thing, because all those cores, even if they are dried enough, there are the possibilities of the generation of the steams and other kind of binders that will be at elevated temperature transformed into gases, and those gases need to be escaped appropriately before the casting solidifies. If it is escaped after solidification, they will make a mark on those castings, and that will be the blowholes, and that will be a very, very detrimental for those product of the casting. So permeability has to be ensured. And the reason is that in many of the cases, cores are surrounded by molten metal, so the possibility of the generation of the gas is more. So the permeability is more crucial than the permeability of the moulding sand in many cases. Second one, strength, again very, very important, because they are also surrounded by molten metal, and the probability of the turbulence in this molten metal are very great, appreciably higher. And at appreciably higher, in the storm of molten metal, it has to strong enough in order to retain its shape. Otherwise, any kind of breakage or crack, that will result in the defective casting. The third one is hardness. So their skins and other things are not jeopardized all the flow of the molten metal. If it is jeopardized, then definitely again internal features of the castings will be not accepted. So hardness, strength and permeability has to be maintained for those cores. Now there comes the question of what binds the core sand. So core binders, they are also relevant, because the most commonly used core binders are plastics of the urea or the phenol-formaldehyde groups and furan resins. So these kind of organic chemicals are responsible to act as a binding of those sands with each other, and that is required for the strength of the core. And there are three categories: different resin binders, cold setting, cold boxes, gas-hardened or hot curing. One is everything is done and set in the cold room temperature, and sometimes of gas is provided in order to make it hard, or the cold boxes, or other than that at elevated temperature with some curing activity, those binders will bind all those things associated with those sands. So different strategies are there. So what is cold setting? It is a process begin to harden after the last additive. Additives are used in order to bind those sands, and has been stirred into the sand like cement does. Cement is a binding agent, and that will ensure the strength. So it acts as a cement for the cold setting, and they are chemically self-setting process. Just like self-setting in case of cement, the moisture goes away, and then the binding is become hard and hard. So here also they are chemically self-setting processes, and common examples are the furan resin. They are the typical properties of all those chemical compounds, organic compounds, or the phenol-formaldehyde resins, which are acid catalyzed with some kind of acid environment, and that way they ensure the bindings of those sands. And they begin to cure after sulfonic acid is stirred into the sand. So some chemical treatment with the acid contamination, and that way they set, And the timing, how much timing they will be exposed to this process, and cannot say so slowly, it interferes with the production. Sometimes we need the productivity, short cycle manufacturing in order to produce that, so the timing and the exposure and other things are also crucial. The other part is another domain is the cold box or gas hardened process that introduced a gas to the core box which reacts chemically to the hardened core binder. So, gas is a chemical agent. And for example, the sands are enriched with those furan resins or epoxies and can be hardened by introducing a candidate active gases, that is sulfur dioxide, water glass or sodium silicate, and can be hardened by using all those CO2 process gases and other things. So, gas contaminated hardening process is done. That is why it is known as gas hardened process. This is all to inflict the strength in the core. And there are methods where hot curing, because at elevated temperature the binding will result, more strength in the binding will be there, and that method relies on the introduction of heat. And linseed core oils also, that additional core binder is also set with a hot curing process, so that elevated temperature with the random motions of the molecules and atoms, the binding things become stronger and stronger, and which is very crucial for the strength, retention of the strength of the core even at high temperature, or inflicting hot strength of those core. In other shell processes, does not need to do chemistry, comes with the premix one. It is an easy one, or quoted from the distributor, and the chemical they put it into the hard shell and then baked. So, not many chemical additive activity has to be done. It is an off shelf, it can be purchased as a bought out item, and then it will be put into that and create a hard shell when baked. And usually these do not need to cure all the way much, only hardening, and that will be a self binding activity. So, there are different boxes, hot boxes and warm boxes. Use those things at elevated temperature to ensure those kind of bonding in the chemical environment. Then another things which are associated with these core making and placement process, there are chaplet and chills. What is chaplet? A small metal insert or spacer used in molds to provide core support. A hanging core, how it will be hanged in a concentric position. The chaplet is the candidate to do that, and that will also melt away after doing its duty to make it in a concentric placement in the core after the pouring of the molten metal. And what is chill? A metal inserts of the sand mold used to produce local chilling and equalize the rate of solidification through the casting. So, cooling process is very, very important. The faster you cool, the smaller the grain size is, lower the bigger one, the smaller one higher strength and other things. So, one has to provide some kind of directional solidification, directional cooling, and some metal inserts can ensure those directional chill at appropriate places, so those hot tears and other kind of crack will not there. So, some control, it is a very difficult process to control all those cooling directions and solidification directions, but chill can give a device, at least some part of it, where the criticality of all those solidification, shrinkage, cracking and other things, chills are there in order to guide all those cooling process in an appropriate way, so that those kind of defects and other things will not appear in the times of very, very critical places of those castings. In the next slides, this slides one can see these chaplets. Chaplets are made of a very thin sheet type of metals, maybe a blunt product, and they are specifically can withstand the support of the core, and it will be a self-sacrificial one. They will also melt away, not disturbing any kind of problem in terms of the characteristics of those molten metals. But up to the molten metal, they will place those cores in different kind of overhanging position, concentrating position, and then they will be sacrificed themselves in order to put the core in the right position, and then they will melt away along the cast metal and their purpose is served. Alignment is maintained, concentricity is maintained, overhanging part of it is appropriately positioned with those things, and this is known as chaplets. And the external chills. So, some external chills will be provided, that is compared with the left and the right one can find it out. Internal external heat sinks, it is acting as some kind of heat sinks, so that whatever the crack in the B figure will not appear, whatever is there in the left figure, because of the position of the chills. The chills will ensure the fast cooling of all those places, so that the internal in the critical positions, all those things will not be a crack generation because of the non-uniform cooling. So that is a very important position, but only need expertise, knowledge and experience in order to rapid freezing in certain regions of the casting to ensure there are least possibility of the crack, and those things are known as external chills. Only an expert person can find it out that these are the positions of the eye sections and corner where the possibility of the non-uniform cooling and generation of some kind of cracks, internal hot tears and other things will be there from non-uniform cooling. So the chills has to be provided for the rapid freezing, so that the question does not arise of all those shrinkage problem associated with those cooling. And that's all for today. We have discussed about the different aspects of the core making process, what are their role, how they are placed, how they are made, and how the overhanging positions, the chaplets and the chills, and we have detailed discussion in the entire making process of those core sand making, and what are their features, similarity with the molding sand, and some features which are slightly different from there, and what is their utility. And we have seen those products as a sample cases where they are utilized in order to manufacture those engine blocks and other things, as a very crucial method of generation of hollow sections in the cavities. Thank you.